friends, welcome to JE Cloud, and this is your cloud mentor Gaurish. And today we are going to learn complex numbers or do some problems related to complex numbers from mathematics. So let's look at the questions. Yes, uh, the multiplicative inverse of root 5 plus 3i is what? So for finding multiplicative inverse, let's take this one, that is, this is the combination where we need to take the multiplicative inverse. So let z equal to root 5 plus 3i, root 5 plus 3i. Then 1 by z is the multiplicative inverse, right? Yes, so 1 by root 5 plus 3i, 1 by root 5 plus 3i, that is the multiplicative inverse, and we are taking the conjugate of the denominator, that is root 5 plus 3i, so and multiplying that with numerator and denominator, so we get 1 by root 5 plus 3i multiplied by, yes, the conjugate, that is the sign changes, root 5 minus 3i by root 5 minus 3i, root 5 minus 3i. So we get root 5 minus 3i divided by root 5 the whole square, that is 5. 5 minus 3i the whole square, that is 9i square. 5 minus 9i square. So how do we get that? Yes, that is the a plus b into a minus b. It's the same formula, we know that a plus b into a minus b, that is will be equal to a square minus b square. So applying that, we got this, that is 5 minus 9i square, and I square we know it is minus 1. I square is minus 1, and so applying that, we get that it is root 5 minus 3i by yes, 5 plus 9, that is root 5 minus 3i by 14. Otherwise I can write it as, yes, root 5 by 14 minus 3i by 14. So let's look at the options. Yes, option B is the right answer. Option B is the right answer. So that's it, and let's move to the next question. If 1 plus I by 1 minus I the whole cube minus 1 minus I by 1 plus I the whole cube equal to x plus iy, then xy is equal to x. We need to find the x and y. So let's look at the answer. First of all, we need to simplify the 1 plus I by 1 minus I by taking the conjugate, that is 1 plus I by 1 minus I is equal to 1 plus I of 1 plus by 1 minus I multiplied by 1, taking the conjugate of the denominator, that is 1 plus I, so multiplying that with 1 plus I by 1 plus I, so we get 1 plus I the whole square, 1 plus I the whole square divided by 1 plus I the whole square divided by 1 square minus I square, right? Yes, so here expanding this 1 plus I the whole square, that is we get 1 square plus I square plus 2i divided by, yes, I square is minus 1, so that is 1 plus 1, and that is 2. Yes, so here 1 square plus I square is minus 1, so 1 minus minus 1, I will write it once more, that is 1, I square is minus 1, so 1 minus 1 plus 2i whole divided by 2, so we get 2i by 2, and that's it, it is I, so I, that is I, and the next term, that is 1 minus I by 1 plus I, that is simply the reciprocal of the first one, so we can write this one the first one is I and the second one is 1 by I. So we get, yes, this or 1 plus I by 1 minus I minus 1 minus I by 1 plus I, the whole cube, right? The whole cube is equal to I cube minus 1 by I the whole cube, right? Yes. I cube is I square is minus 1, so minus 1 of I, that is minus I. I cube is minus I. I cube, sorry, I cube, not I cube, this I cube. I cube equal to minus I. So applying that, that is minus I minus 1 cube is 1 and I cube is again, that is 1 by minus I. So that will be equal to, so here that is minus I plus 1 by I, and I have to simplify this I and I don't like this i's, so I'm going to write it as minus I plus 1 by I multiplied by I by I. Is there any difference? No, I by I is 1, there is no change, but we can now apply some formulas, or that is I multiplied by I is I square is minus 1, so that term is gone. That is minus I plus I by minus 1, we get minus 1. So that is minus I minus I minus I minus I, that is minus 2I. So we got minus 2I, and we know that from the question, that is this one is equal to x plus 2y, and this one we got as minus 2y minus 2I. So we can write minus 2I is equal to x plus iy, is equal to x plus iy. From this, there's the imaginary, the real part, that is x, it is 0 here, and the imaginary part, that is y, is minus 2 here. Y is minus 2 and x is 0, x equal to 0. So option, that is 0 minus 2, 0 minus 2, which is option 0 minus 2. So option A is the right answer here. So moving to the next question. If 1 plus I the whole square by 2 minus I equal to x plus iy, then the value of x plus y is equal to dash. So let's do it. Okay, so 1 plus I the whole square divided by 2 minus I, 2 minus I, and that's equal to x plus iy. X plus iy. 2 minus I, and that's equal to x plus iy. Okay, then we are going to expand this 1 plus I square, 1 plus I the whole square, and taking the conjugate of the denominator and multiplying with the numerator and denominator. Okay, so that we get 1 square plus I square plus I square plus 2I by 2 minus I, 2 minus I multiplied by 2 plus I, that is the conjugate of denominator, 2 plus I by 2 plus I, and that's equal to x plus iy, x plus iy. Okay, then here I square is minus 1, so that gets cancelled, and we get 2i multiplied by 2 plus I, 2 plus I divided by, this is a plus b, a minus b, that means it will be 2 square minus I square, 2 square minus I square, and that's equal to x plus iy. Okay, then that is multiplying with 2i, 2 inside we get 4i, I and I, that is minus I, so minus 2, 4i minus 2 divided by 4 minus minus 1. I square is minus 1. So 4 plus 1, that is 5. So 4 plus 1, that's equal to x plus iy, and we get uh, that is 4i divided by 5 minus 2 by 5, and that's equal to x plus iy. So here equating the imaginary and real parts, the real part is x will be this minus 2 5 minus 2 by 5. Okay, so x equal to minus 2 by 5, and imaginary part, that is y, that is with the I, so y equal to plus 4 by 5. So x plus y is the required answer. So x plus y equal to yes, x is minus 2 by 5 minus 2 by 5 plus 4 by 5. So that will be, yes, 2 by 5. 2 by 5. Let's look at the options. Yes, option C is the right answer. 2 by 5. Next question. The real value of alpha 4 is the expression I minus 1 minus I sine alpha by 1 plus 2 I sine alpha is purely real is where n element of n. Oh, it is we have to find in which of the options it is purely real. So here we have this one, that is I 1 minus I sine alpha by 1 plus 2 I sine alpha. We have to change this form to the standard form, that is a plus ib of a complex number a plus ib. So we are going to multiply it with the conjugate of the denominator, that is 1 minus 2 I sine alpha divided by 1 plus 1 minus 2 I sine alpha. So that's it, and we are going to multiply it with, okay, we are going to multiply, that is we get, and we get 1 plus 1 multiplied by minus 2 sin I sine alpha, that is minus 2 I sine alpha alpha, and multiplying with minus I sine alpha, it is minus I sine alpha, and with this, so we get it is maybe I should write here 1 minus 2 I sine alpha minus I sine alpha, and multiplying this with this, so I get 2 I square sine square alpha divided by the whole divided by, yes, 1 square minus a square minus b square, that is 2 I sine alpha the whole square. So we get 1 minus 3 I sine alpha in alpha, and expanding this, this I square is minus 1, so minus 2, I lost it. Is it correct? Yes, it was correct, sorry. So 1 minus 3 2 I sine alpha and minus I sine alpha, we get as 3 sine alpha, and minus 2 sine square alpha, okay, and then the whole divided by that is 1 minus, sorry, 1 plus the I square here 4, and I square, that is minus 1 and minus 1 and minus, so plus 1 plus 4 sine square alpha, 1 plus 4 sine square alpha, 1 minus 3 I sine alpha, 3 sine alpha minus 2 sine square alpha, 2 sine square alpha divided by 1 plus 4 sine square alpha. So this is the form we got at last. And we said that it must be the value must be real. So that means the imaginary part must be 0. Imaginary part must be 0. That is, imaginary part of z must be 0. So that means the imaginary part will be of this one. That is, yes, minus 3 sine alpha by 1 plus 4 sine square alpha. I can write that. Okay. Split. If we split it into two parts, then we get 1 minus 2 sine square alpha. We don't need that. Oh, yes, 1 minus 2 sine square alpha by 1 plus 4 sine square alpha minus 3 sine alpha by 1 plus 4 sine square alpha. 3i sine alpha sine square alpha, and this is the imaginary part. So we are needed to, or we are required to equate this with 0, because it must be only real, must not be imaginary. Imaginary part must be 0. This is the question, this condition given in the question. Okay, purely real. Okay, so the expression is purely real, not alpha. It must be purely real. So that means minus 3 I sine alpha. Okay, leave that I. Minus 3 sine alpha. This imaginary part is minus 3 sine alpha divided by 1 plus 4 sine square alpha, and that must be equal to 0. So cross multiplying this, get 0, and we get minus 3 sine alpha. Sine alpha is 0, equal to 0. That means sine alpha must be equal to 0. Sine alpha must be equal to 0. Sine alpha will be, sine will be 0 when alpha is equal to n pi. Okay, so it is the multiple of 180 degree. If it is multiple of 180 degree, then we can say sine, the value of sine will be 0. So which is the option? Yes, option C is the right answer. Option C is the right answer. So next question: if a real this is z square equal to 0 and modulus of z equal to 2, then yes, we have to find the value of z. So let z equal to x plus iy. That's the general form, x plus iy. Then here it is x z square. Z square means x plus y the whole square, x plus iy the whole square. So expanding, we get x square plus I square y square y square I square y square plus 2 2 or I taken out, 2xy, I of 2xy. So that's the expanded form, and from this we can write, that is x square, I square is minus 1, so x square minus y square plus I of 2xy. And here the real part is x minus y square, and the imaginary part is 2xy. And now we have the square is 0. The real part of z square is 0. That means real part is x square minus y square. So x square minus y square is equal to 0. That means x square equal to y square, and otherwise x equal to plus or minus y, right? Yes, that means x equal to plus y or x equal to minus y. Yes, and now we have the other condition, that is modulus of z equal to 2. Modulus of z equal to 2. So that means modulus of z equal to 2 means we can write modulus of z square, that is equal to 4, and the modulus of is square, otherwise we can write x square plus y square. S square plus y square equal to 4, right? Yes. From this we can x equal to y, we can write I square plus y square, plus y square equal to 4. We have got the x equal to y, so we can write y square plus y square equal to 4. That means 2y square equal to 4 and y square equal to 2. That means y equal to plus or minus 2. So we got y now, and we need to find the x also. So how can we find the x? We know x is plus or minus y, so the same we can apply. That is x equal to plus or minus, oh, here it is root 2. Okay, y is plus or minus root 2, so x is also plus or minus root 2. That is, we have the x equal to plus or minus y, right? Yes, so, or x equal to y. So y have the two values. Plus or minus root 2. So x should also have the that two values, plus or minus root 2. So x plus y. So z equal to x plus iy. That's equal to, that is plus or minus root 2 plus or minus I root 2. So here we got the answer, that is plus or minus root 2 plus or minus I root 2. So let's look at the options. Yes, option A is the right answer. This minus or plus, we can also prove that minus or plus if we take the x as minus y here, where here we have used the x as plus 5, so we got this answer. If you use the other one, it's x equal to minus 5 here, so I can show that also. It's x, take x as minus y, x equal to minus y, so we get minus y the whole square, yes, plus y square, that is equal to 4, and which implies, yes, minus y the whole square, that is y square, that is also 2y square equal to 4, and we get y equal to, yes, y equal to plus or minus root 2. And now the x will be minus y, so we have taken x equal to minus y, so x equal to minus or plus root 2, minus or plus root 2, minus or plus y, so minus or plus, so that's the option A. In that way also the option A is right answer. We got it. Next question. The value of 1 plus I square plus 1 raised to I raised to 4 plus I raised to 6 plus etc. up to 2 raised to n, I raised to 2 raised to n is dash, positive, negative, 0 or dash, or cannot be determined. Here let s equal to 1 plus I square I square plus I raised to 4 plus I raised to 6 plus etc. I raised to 2n, right? So that means it is 1 minus 1 plus 1 minus 1 plus 1 minus etc up to plus minus 1 the whole raised to n, right? Minus 1 the whole raised to n. So here the value of s depends upon depends upon the n, the value of n. So therefore the value cannot be determined, so option D is the right answer because it is dependent on n. So option D is the right answer. I hope you got how we got these values. That is I square is minus 1 and I raised to 4k is positive, that is plus 1 here, and I raised to 4k plus 2. I am writing this journal. I raised to 4k is 1, and here I raised to 4k plus 2, that is minus 1, and again that goes on. So that's it, and at the end, that is I raised to 2, and I can write it as I square of I raised to n. So I square is minus 1, so minus 1 the whole raised to n. Okay, That's it. And now next question. The value of sum sigma n equal to 1 to 13 I raised to n plus I raised to n plus 1, where I equal to root minus 1, is equal to what? So here the sigma I equal to, n equal to 1 to 13 I raised to n plus I raised to n plus 1. If we do expand this, it is like this: 1 I raised to giving 1 and 2 something, I raised to 1 plus I raised to 2 plus etc up to I raised to 13, right? Yes. Plus here if we give 1, that is 1 plus 1 2, so I raised to 2 plus I raised to 3 plus etc up to I raised to last what is 13, 13 plus 1, that is 40. It's 40. And now how to solve this sum? We know that the sum of any four consecutive powers of iota is 0. That is, if the four consecutive, I am taking example first 4, that is I next one the I square equal to minus 1, you know. Yes, this I is iota, you know, iota, it is called as iota. And I square equal minus 1, and I cube, that is minus 1 of I, that is minus I, and I raised to 4, that will be equal to, yes, minus I of I, that is minus I square. Minus I square is minus 1, so minus of minus 1, that is 1. So if we add these four ones, that is I, next one it is I minus 1, next this minus I, and the last one that is plus 1. So here plus I and minus I cancels, and minus 1 and plus 1 cancels, so we get the sum as 0. Like that, the consecutive four sums, four powers of this iota is having zeros. So up to the 4 consecutive, right? So the power of 4 below 13, or the multiple of 4 below 13 is 12, or near 13 is 12. So 12 is 4 multiplied by 3, so it is a multiple of 4, so that is okay. So that is, they will be 0 up to 12th term, that will be 0, and we have left I raised to 13, and plus here also up to 12 I raised to 12, it will be 0, and now we have left I raised to so here also the first it starts from I square, and the four consecutive pairs or sets will be up to I raised to 13, and they cancel out as 0, and we get I raised to 14 left. I raised to 14, so that is I raised to 13 will be I raised to I raised to 4k will be equal to 0. K will be equal to 1 2 1 2 3 4 etc. That is I raised to 4k, that we can split this I raised to 13 into I raised to 13 into I raised to 4 multiplied by 3, that is I raised to 13 and I, so I raised to 13 will be I, that is 1 multiplied I raised to 4k is 1 multiplied by I, that is I. Okay, and I raised to 14 we can also split into I raised to 14 will be equal to, so I raised to 14 will be equal to I raised to 12, that is multiple of 4 multiplied by I raised to 2. Okay, so we get I square, and I square, oh, so we can write I plus I square, and I square is minus 1, so I minus 1 is the answer. So option B is the right answer. Next question. I 1 plus I by 1 minus I the whole raised to x equal to 1, then you have to find the x. Here again we must make this expression into the standard form, that is a plus ib. So 1 plus I by 1 minus I can be we should take the conjugate of the denominator and multiply it, that is 1 plus I divided by 1 plus I the whole raised to n, the whole raised to xx, that is equal to 1, right? Yes. So before that we have to simplify that. That is 1 plus 1 plus I of 1 plus I, that is 1 plus I the whole square divided by 1 square minus I square. Okay, 1 square minus I square, and this and the whole raised to x, right? Yes. So 1 plus I the whole square, that will be equal to 1 square plus 2I plus I square, and that divided by I square minus I square, 1 minus I square, that will be I square is minus 1, so 1 plus 1, that is 2, the whole raised to x. So here also this is 1 square is 1, and here I square is minus 1, and that cancels out, so we get 2I divided by 2, the whole raised to x, and that's 2I, 2 cancels, and here get I raised to x, and it is told that I raised to x, this value I raised to x must be equal to 1, so I raised to x equal to 1. I have told that the here in the options it is taken as n, so I can say that we know I raised to 4n is equal to 1, so x must be 4n, x must be equal to 4n. So that option B is the right answer. Next question. The real value of theta 4, which the expression I plus I 1 plus I cos theta by 1 minus 2 I cos theta is a real number, is. So here also we are going to simplify the expression and then find the answer. So that is 1 plus I cos theta divided by 1 minus 2 I cos theta, and taking conjugate and multiplying, that is 1 plus 2I cos theta by 1 plus 2I cos theta. So here it will be 1 multiplied by 1 and 1 multiplied by 2I cos theta, that is 2I cos theta, 2I cos theta, and here also I cos theta multiplied by 1, that is I cos theta, I cos theta, and here I cos theta again multiplied by 2I cos theta, that is 2I square cos square theta, 2I square cos square theta, and that whole divided by, that is here is a plus b of a minus b, that is I square minus 2I cos theta the whole square. So that will be equal to here 1 plus, what is this, I minus cos theta, 1 minus 2I cos theta 1 of 1, that is I cos theta of 1, that is I, what is this, oh this is plus, okay, this is plus sign, okay, sorry. And now 2I cos theta plus I cos theta, that is 3 cos theta, 3I cos theta, 3I cos theta, and we have left 2I square cos theta, 2I square, oh 2I square cos theta, 2I square cos square theta, and that divided by 1. Here we must look at that the I square, 2I square is minus 1, so that we can change this plus to minus, so minus 2 cos square theta, and the whole divided by 1, and this 2 square is 4, and here the I square is minus 1 and minus of minus, so plus 1 plus 4 cos square theta. Here we can split it into the real and imaginary parts, that is real parts includes the those which does not have I, that is 1 minus 2 2 cos square theta, 2 cos square theta divided by 1 plus cos 4 cos square theta, and including I, that is plus 3I cos theta, or I taken out, I of 3 cos theta, 3 cos theta divided by 1 plus 4 cos square theta. Now it is said that the value of theta for which the expression is a real number. The expression must be a real number. So we have already done such a question before. So this imaginary part must be equal to 0. Imaginary part must be equal to 0. That means this part will be 0. That is 3 cos theta divided by 1 plus 4 cos square theta must be equal to 0. That means must be equal to 0. That means 3 cos theta equal to 0 or cos theta equal to 0. Cos theta equal to 0, which implies theta will be equal to. Now let's look at the options. Theta must be equal to 0 if n pi plus pi by 4. It is not right. Yes, it is n pi plus minus 1 raised to n pi by 4. So cos theta will be 0 if n pi plus minus 1 raised to n pi by 4. Okay, so that's the option B is the right answer. So next question. So given z equal to q plus ir by 1 plus p, then p plus iq by 1 plus r equal to I 1 plus iz by 1 minus iz. If which one? So this question we can do it by, you know that here z is equal to q plus q plus ir by 1 plus p, and here p plus iq by 1 plus r. 1 plus r is equal to, I don't know, this is more difficult to write with the mouse. Okay, sorry. So 1 plus I z, wait a second, I am changing my mouse. Okay, done. 1 plus I z by 1 minus I z, 1 minus I z. Okay, it is given here. So I am going to substitute the value of z here directly and simplify to get the which of the results is true. Okay, and now p plus q. So p plus iq by 1 plus r is equal to 1 plus I z. In the place of z I am giving q plus ir. I think I must first solve the RHS, that is 1 plus iz by 1 minus iz, then equate it with p plus iq by 1 plus r. So 1 plus I of q plus ir divided by 1 plus p divided by 1 plus p, that is the z. So I have given the value of z here, and in the denominator, that is 1 minus I of same q plus ir divided by 1 plus p, that's it. So taking LC, I get 1 plus p. So sorry, taking LC, I get 1 plus p plus I given invert, that is we get iq, that is iota q. Okay, iota q plus I square, that is minus 1 and minus r, that means this minus r, and divided by 1 plus p by, here I am taking LC, that is 1 plus p and 1 plus p, here also it will be minus iq and minus gone inside, that will be minus I square. I square is already minus 1 minus of minus plus, so plus r, So that's it, and 1 plus q and get cancelled here. So we get 1 plus p plus iq, 1 plus p plus iq minus, which was, what is this? This is r, minus r by 1 plus p minus iq plus r. So now we can equate this with p plus iq by 1 plus r. So that's equal to p plus iq by 1 plus r. So cross multiplying we get p plus iq of 1 plus p minus iq plus r is equal to 1 plus p 1 plus, just a minute. Okay. 1 plus 1 plus p minus iq plus r multiplied by the it is plus iq, and here it is minus r, sorry, minus r, and it is multiplied by 1 plus r. Okay, that's it. And here also I think I have got it wrong. No, it's wrong, it's right. So and I'm multiplying this, that is p multiplied by 1 p multiplied 1 by 1 p, and p of p square plus p square, and p given to here minus pq of I, and here p plus p multiplied by r, that is pr, and now here iq is given here, iq of 1, that is iq, and iq of p, that is again plus pqi, and iq of r, that will be iq of r, right? Yes, p I have given q2 here, that is q. Where is that q? I didn't return. Yes, iq of 1, yes, iq of 1, that is iq here, and iq of p, that is pqi, then iq of minus iq, that will be I square minus I square q square, that is minus I square q square, that will be plus I square plus q square. Okay, and minus iq, so iq multiplied by r will be equal to qri. Okay, I think that's right, and the right I am expanding the RHS, that will be also 1 multiplied by 1 multiplied by r, that is um, that is r, and here p multiplied by 1 p, that is p, and here p multiplied by r, that is pr, and here iq multiplied by 1, that is iq, and iq multiplied by r, that is iqr, and r multiplied by minus r multiplied by 1 minus r, and minus r multiplied by r, that is minus r square. Now we can cancel out this minus pqi and plus pqi, and here we can cancel from here p, here also p, and pr and pr gets cancelled, iq and iq gets cancelled. Okay, here r and minus r gets cancelled. Now what is left here? This p square left, and minus I square q, that is minus 1, so minus of minus, that is plus, So plus q square, and what is left? Yes, qri. So no, it is cancelled here. Qri or iqr and qri are cancelled, so that's it, I think. And nothing left, I think. So uh, in the left hand side it is only this one, and in the right hand side only 1 minus r square, right? 1 minus r square. So we got, taking r square to the leftwards, we get p square plus q square plus r square, that is equal to 1. So let's look at the option p square plus r square equal to 1. So yes, option A, right answer here. Okay, next question. If z equal to x plus iy lies in the third quadrant, then conjugate of z by z also lies in the third quadrant if which of the following conditions? Here z equal to x plus iy, right? Yes, we have to find conjugate of z by z, and that is conjugate of z is x minus iy, changing the sign, x minus iy, and that divided by z is x plus iy, right? Taking the simplifying this by x plus iy, simplifying this by taking the conjugate of the denominator and multiplying it with denominator and numerator. So x minus iy by x minus iy. Okay, now we get x minus iy of x minus iy, that is x square, I mean x minus iy the whole square, x minus iy the whole square, divided by x plus y x square minus iy the whole square, that is I square y square. The I square is minus 1, so minus of minus, so plus 1, that is x plus y square. Now we get, by expanding we get x square plus minus iy the whole square, that means I square, y square, that will be minus y square, plus sorry, minus 2xyi, 2xyi divided by x square plus y square. So that will be x square plus y square, sorry, x square minus y square divided by x square plus y square, and minus imaginary part, that is 2xy I by x square plus y square. And this all that this one, I mean, is also, this is a z bar or z conjugate by z, must also lie in the third quadrant. For lying in the third quadrant, the x and y coordinate must be negative. Okay, x and y coordinates must be negative. That means the imaginary and the real parts must be negative. So which of the following conditions satisfy that the imaginary and the real parts are negative? For this part becoming the negative, that means the y square. um, let's look at the first option. If x is greater than y is greater than 0, then it will not be 0, it will not be negative. And if x is less than y and less than 0, both are negative, and if we apply that here, it will be negative, the real part will be negative. And let's look at the imaginary part also. If it's negative, both are negative, then this will be negative. So simply we can say that option option B is the right answer. Option B is the right answer. Okay, yes. Now moving to the next question. Conjugate of 2 minus I by 1 minus 2i the whole square is dash. So taking the conjugate, so let's find it. The conjugate of z is z bar. Oh, it is not. Hmm, the conjugate of z is z bar. Sorry. And that's we are writing the minus I instead of I. Okay, minus I instead of I. So we get here instead of I minus I, then minus of minus, that will be plus. So that will be 2 plus I, 2 plus I divided by 1 plus 2i. Here also we are substituting I with minus I, so we get 1 plus 2i the whole square, 1 plus 2i the whole square. So here we need to make it into the standard form, so uh, it is 2 plus I divided by expanding this, we get 1 square, 1 square minus 4 plus 4i, plus 4i, and we get it as 2 plus I, 2 plus I, 2 plus I divided by 4i minus 3, 4i minus 4i minus 3, and taking the conjugate and multiplying both numerator and denominator, we get 4i plus 3 divided by 4i plus 3. So we get by multiplying, we get here denominator will be 4i the whole square minus 3 the whole square, minus 3 the whole square. So we get it as 4i the whole square, 4i the whole square minus 3 square, and upon or the numerator will be multiplying, we get it is 2 multiplied by 4, that is 8, and 2 multiplied by 3, that is 6. So 8 plus 6, that will be 14, and let's do it here. 2 plus 2 multiplied by 4, that is 8, and 2 multiplied by 3, that is 2 multiplied by 4 I, so 8i, sorry, 2 multiplied by 3, that 3, that is 6, and here I multiplied by 4, that is 4i, and I multiplied by 3, that is 3i. Here it is a mistake, that is a 4i multiply 4i, so I square, 4i square, we get it as the by solving, we get 11i plus 2 divided by minus 16 minus 16, 4 square, that is 16, and I square minus 1, so minus 16, 3 square, that is 9, so minus 16 minus 9, so we get the answer, it is I. Okay, so we get yes, it is minus 2 by minus, and changing the sign here, we will get minus 25, and taking, otherwise we get 11i plus 2 by minus 25, and we get the answer minus 2 by 25 plus, I mean it will be minus 11i by 25. So that's the answer. Let's look at the options if it is there. Yes, option B is the right answer, option B. Okay, next question. Sin x plus I cos 2x and cos x minus I sin 2x are conjugate to each other for the value, the given value. We have to find that. So let z equal to sin x plus I cos x. Okay, I cos 2x. Sin x plus I cos 2x, and according to the given conditions, that is cos x minus I sin x sin 2x the conjugate, right? So that means also we can write the conjugate of sin x plus I cos 2x as changing the sign, that is minus here, so that is sin x minus I cos 2x, and that must be equal to the other conjugate, that is cos x minus I sin 2x. It is given there, so that must be equal to cos x minus I sin 2x, and taking them to the left hand side we get sin x, and taking or grouping the real numbers at the one parenthesis and the other in the next parenthesis, so we get sin x minus cos x, which is the real part, and taking this to the left hand side, that is plus, it becomes plus I sin 2x, and taking the I common, so we get I of sin 2x minus cos 2x right? Yes, that must be equal to 0. So here we got that the equating the real and imaginary parts, here the real and imaginary parts must be equal to 0 because RHS is 0, so we can equate this with sin x minus cos x equal to 0, and sin 2x, it is not square, okay, it's 2x, sin 2x, sin 2x, oh what is this, sin 2x minus cos 2x must be equal to 0, right? Yes, so we get, that means sin x equal to cos x and sin 2x is cos 2x, so that means that is tan x equal to 0, and tan 2x equal to 0. That means tan x equal to 0 means x equal to n pi, and here the tan 2x, so 2x equal to 0 means 2x equal to n pi, that means x equal to, here it is n pi, and x equal here n pi by 2, so that's it, and it is not I think so options, it is not possible, right? Yes, so it is not possible, so option D is the right answer. There's no value of x, cannot be both, that is n pi and n pi by 2, so no value of x, that's right, option D is the right answer. Moving to the next question. So in this question, the value of the z plus 3 multiplied by z bar plus 3 is equivalent to dash. So it is z plus 3 of z bar plus 3. It's becoming more difficult to write. Okay, I'm writing once again. Z plus 3 of z bar plus 3. Okay, so we are multiplying z with z bar, that is z bar, z bar, and z multiplied by 3, that is 3z, 3z, and plus 3 multiplied by z bar, that is 3z bar, and 3 multiplied by 3, that is 3 square. So that's it, and that is z and set bar is modulus of z square. It is a property that is modulus of z square is equal to z bar. So, z bar. Oh. Okay, the z square is equal to z bar and plus I am taking the 3 common, so we get 3 of z plus z bar plus 3 square. Okay, and I'm taking into a general form, or we have to change this to a general form or other form like this, so we need to multiply that 2. Here we got a square. If we take an example as a plus b the whole square, we need a square and b square. We have a square and b square now, so it is z plus 3 is here. Let's look if we can convert this one. That is, I can do that like this: z square plus 3 of z plus z bar by 2, and to make it not change I'm multiplying with 2, so they will cancel out, and plus 3 square. So now how is it? Yes, so we can now write it as, yes, that is z plus z bar by 2 is modulus of z. So we can write it as z square plus 2 of 2 taking leftward, 2 of 3 of modulus of z plus 3 square. So that's equal to modulus of yes, z plus 3 the whole square. So option A is the right answer here. Next question. Z minus 1 by z plus 1 is a purely imaginary number. Z not equal to minus 1, then the value of z, I mean the modulus of z is dash. So um, here here let z equal x plus y. Okay, x plus iy. Then I can write z minus 1 by z plus 1 as, it's equal to, in the place of z I am giving x plus iy, so x plus iy minus 1 by z plus iy plus 1, and rearranging that we get the real parts x minus 1 and plus iy divided by x plus 1 plus iy. To simplify, I am multiplying it with the conjugate of the denominator, that is x plus y minus iy divided by x plus y minus iy. Okay, and now multiplying we get x plus y, x minus 1 of x plus y, we get x minus 1 of x plus y, x minus 1 of x plus y, and minus I am taking multiplying with this x minus 1 with the I minus iy, so we get minus iy of x minus 1 minus iy of x minus 1 and plus, and next we are taking iy plus iy of x plus y and iy of minus iy. We get minus I square y square y square. So in the denominator, that is x plus y of x minus y, that or in the term or in that form, so we get x plus 1 the whole square, x plus 1 the whole square plus y square. I think something is burning in the kitchen, sorry. And x plus 1 the whole square plus y square, that's it. And now simplifying, we get we can say that by simplifying is z minus 1 by z plus 1 is equal to I want to simplify that, that is x square minus 1 multiplying x square, we get x square minus 1 plus taking iy common, iy of x plus 1 minus x plus 1 minus x plus 1 and plus y square, because minus I square is minus 1, so minus 1 minus plus, and divided by the same, that is x plus 1 the whole square plus y square, x plus 1 the whole square plus y square. So that's it. And now simplifying, we get, that is I can write z minus 1 by z plus 1 is equal to, yes, here they cancels out, so we get x square plus y square minus 1, that's the real parts here, minus 1 divided by the denominator, that is x plus 1 the whole square plus y square, and the imaginary part here is I of 2y, there is 1 plus 1, that is 2 I of 2y. So we get I of 2y divided by x plus 1 the whole square plus y square. Okay, so that's it. And now and now we know that this told that in the question this value, this expression is purely imaginary real number. Sorry, it is purely imaginary. That means z minus 1 by z plus 1 is purely imaginary. So I can say that the real part of z minus z minus 1 by z plus 1 is equal to 0. Okay, so real part of z, which this is x square plus y square minus 1 by x plus 1 the whole square plus y square. So I am applying that here, that is we get x square plus y square minus 1 by x plus 1 the whole square plus y square, and that is equal to 0. Equating that with 0, we get, so from this we can write x square plus y square minus 1 equal to 0. Okay, equal to 0, and from this we can write x square plus y square is equal to 1, and this x square plus y square is nothing but it is the modulus of z. So because we said that z equal to x plus iy, so x square plus y square is equal to modulus of z, and we can write it modulus of z square is equal to 1. It is modulus of z square. Okay, this modulus is the quantities, only the magnitudes. And now we can write z square equal to 1, and that means z equal to also z is the modulus of z is equal to 1. So what is this question? Yes, the value of modulus of z, that is equal to 1. Option B is the right answer. Next question. If modulus of z1 is equal to z2 is equal to etc up to zn, that is equal to 1, then the value of z1 plus z2 plus z3 plus z etc up to zn is dash. Wow. So we have modulus of z1 zk I can write general as zk is equal to 1, where k can be 1 2 etc up to n. Okay, and we have this set modulus of zk is equal to 1, so zk the whole square I can write it as 1. It is also 1, which implies zk of modulus of z or z bar is equal to z square, modulus of z square. So I can write this as zk of zk bar is equal to 1, which implies zk bar equal to 1 by zk, right? 1 by zk. And now therefore modulus of z1 plus z2 plus etc up to zn is equal to yes, z1 plus z2 plus z3 etc up to zn, the whole conjugate or the whole bar, that is modulus of z. It is a property we can write the modulus of z is equal to modulus of z bar. Okay, modulus of z is equal to modulus of z bar, and now that is equal to, we can split that conjugate into two individual terms, that is z1 bar plus z2 bar plus z3 bar plus etc up to zn bar. And now we can apply this property we have found here, that is 1 by, yes, in the place of 1 by z1 bar we can write 1 by z1 1 by z1 plus 1 by z2 plus 1 by etc up to 1 by zn, 1 by zn. And now I think that is the option, this thing is in the option, that is option C is the right answer. Okay, that was easy. Okay, now moving to the next question. If alpha and beta are different complex numbers with the beta or modulus of beta is equal to 1, then beta minus alpha by 1 minus alpha bar beta, the whole modulus is equal to dash. In this question we have, it is told that the modulus of beta is equal to 1, modulus of beta is equal to 1, and we have the expression beta minus alpha divided by 1 minus alpha bar beta, and I am writing this 1 as beta. Already we know that modulus of beta equal to 1, or modulus of beta I can write it as beta of beta bar, beta of beta bar, that is beta of beta bar, that is equal to beta modulus of beta the whole square. Okay, whole square. And now because beta is equal to 1, so modulus of beta is equal to 1, so modulus of beta square also equal to 1, so I can substitute the value of 1 as beta minus alpha by yes, beta of beta bar minus alpha beta and now beta minus alpha, oh god, beta minus alpha by taking the beta common, so you get of beta of beta common, taking beta common, beta common, we get here left this beta bar of beta bar minus alpha bar, beta bar minus alpha bar, and the whole modulus. And I am taking that beta 1 by beta in the outwards, so we get 1 by modulus of beta minus alpha by beta bar minus alpha bar, beta bar minus alpha bar, and that's nothing but we can cancel, and we will get 1 because modulus of z is equal to modulus of z bar. So that's all. And 1 by modulus of beta already we know that there's 1, so 1 by 1, that is equal to 1. So the value of this expression is equal to 1, so option C is the right answer here. Next question. If modulus of z plus 1 equal to z plus 2 of 1 plus I, then the value of z is dash. So what is that? We can do this problem by assuming any of the options as the z. Okay, then substituting that in the LHS and RHS. If that LHS and RHS is got same, then that option is right answer. First I am taking the option A as z, so z equal to 1 by 2 minus 2i, and applying that z in the LHS. LHS is, yes, modulus of z plus 1, and I am writing that as 1 by 2 minus 2i, that is z be taken, that is option A now, and minus 2i, what is that? Yes, we are writing yes, z plus 1, so plus 1, okay, plus 1, and now we get, what is that? Yes, 1 plus 1 by 2, that is 3 by 2, so modulus of 3 by 2 minus 2i, 3 by 2 minus 2i, and that is, we get, if you take the modulus, this is now a number in the form of a plus ib, so taking modulus we can write root of yes, a square, that is 9 by 4, 3 square by 2 square, 9 by 4, and plus 2 square, that is 4, plus 4, and that will be equal to root of 25 by root of 25 by root of 4, no, root of 25 by 2, and that's equal to 5 by 2, and that's equal to 5 by 2. We got 5 by 2 as LHS, and now we are getting RHS. RHS is here, it is z plus 2 of 1 plus I, z plus 2 of 1 plus I, z plus 2 of 1 plus I, and I am applying the result here. Z is, we have taken 1 by 2 minus 2i, so 1 by 2 minus 2i plus 2 of 1 plus I, this I, 2 of 1 plus I, okay. Now we get, by expanding we get, yes, 1 by 2 minus 2i plus 2 plus 2i, 2 plus 2i, and yes, they cancels out, and we get 1 by 2 plus 2, and 1 by 2 plus 2 is nothing but 5 by 2, 5 by 2, so we got 5 by 2, and LHS is equal to RHS here. We got the LHS also 5 by 2, and we got now RHS is equal to 5 by 2, so LHS equal to RHS, that's all. Therefore option A is the right answer. Option A is the right answer itself. Otherwise we have to go for the option B as Z, and then find the right answer, but here A is the right answer. So next question. If Z is a complex number, then Z bar the whole raised to Z bar inverse of Z bar is equal to what? Here Z bar or bar means the conjugate, okay. Yes. And what is the question? Here, let's take z as x plus iy. Then z bar will be equal to z minus iy. Okay, conjugate. And now we need to take the inverse of z bar, that is equal to 1 by z minus 1, z minus iy, and I can change it to the standard form by multiplying the conjugate with it, of the denominator, that is x plus iy, or x plus iy by x plus iy, and now we get, that is x plus iy divided by x square plus y square, right? X square plus y square, because I square y square, so I square will be minus 1 minus, so adding that we get this one. And now we have to find the z bar inverse, of z bar, right? So that is x plus iy divided by x square plus y square. I think it is more good to write like this, that is x square minus iy the whole square. Okay, iy the whole square. And now x square, that is x plus iy by x square minus iy the whole square of z bar is x minus iy. Now we know that this one, or this time we got by multiplying x plus iy and x minus y. So x minus iy, mean x minus iy gets cancelled here, and what left is x plus iy by x plus iy, right? X plus iy by x plus iy. So that is equal to 1. So option 1 is the right answer. That is option A is the right answer. So next question. The complex number z which satisfies the condition 1 plus z by 1 minus z equal to 1 lies on what? It's a circle of the given equation, or the x-axis or the y-axis, or line x plus y equal to 1. Okay, we have to find that. I'm taking z as x plus iy, so we get I plus z by I minus z, modulus will be equal to I plus x plus iy, divided by I minus x plus iy, right? Yes, and that is equal to 1, right? That is equal to 1. Now I can take that I common here, so we get x plus I of 1 plus y by here, giving this minus x or minus to invert of the inverse, we get minus x plus taking I common, plus taking I common, and 1 minus y, okay, so that's equal to 1 also. And now we got, we are taking the modulus, we get root of z square, sorry, here is x square plus 1 plus y, the whole square, 1 plus y the whole square by, yes, the same, that is root of here minus x the whole square plus 1 minus y the whole square, yes, 1 minus y the whole square. And that's equal to 1, so I can write it like this, that is root of z square, I mean x square plus 1 plus y the whole square is equal to root of yes, x square plus 1 minus y the whole square. And now taking the square on both sides, we get x square x square plus 1 square, expanding that this term, that's 1 plus y the whole square, we get x square plus 1 square plus y square plus 2y, and that's equal to x square plus 1 square minus or plus y square minus 2y, and here y square gets cancelled, x square gets cancelled, 1 square gets cancelled. What left is that yes, 2y equal to minus 2y, and from that means taking this, don't cancel out this y from like this, we have to take to minus 2y towards leftwards, we get plus 2y, and that is 4y equal to 0. That means y equal to 0. Y equal to 0 is the equation for x-axis. So x-axis, y equal to 0 is the equation for x-axis. So option, yes, option B, that is the x-axis, right answer. So that was for this part, and we can see the others in the next part of the video. Bye. And to know more about the Cloud Mentor, visit our website. You can Google by typing Cloud Mentor Gaurish. Site appears as the first result, and or simply search Cloud Mentor and you will get the site as the third result. And also you can follow us on different social media platforms, and you can follow us on Instagram, and you can follow on WhatsApp. I have created a WhatsApp group for discussions on different doubts you have, and the links are given in the description box. Also a Telegram group for discussion and the same purpose, and a channel is also formed for giving off your learning steps, and all the links are given in the description box. You can check it later. You can also ask your doubts as comments in YouTube, and if you want more videos which would be uploaded in the coming days, please subscribe our channel and press that bell icon for getting notifications on time.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.